Imagine being 37,000 feet in the air when suddenly every screen in the cockpit goes dark. The hydraulic pressure drops to zero, and the only thing standing between you and disaster is the aircraft itself. Most people would assume that is the end. But what if I told you there are planes so brilliantly engineered that mechanics, the very people who open them up and see their bones, swear they could survive almost any system failure? Today we're going to reveal which aircraft have earned that legendary reputation, and by the end of this video, you will never look at air travel the same way again. The aviation world operates on a principle most passengers never think about, and that principle is redundancy. Every critical system on a modern airliner exists in duplicate or triplicate, sometimes even more. 3 independent hydraulic lines, each one capable of powering every flight surface on the aircraft. Multiple electrical generators, backup batteries, and a hidden emergency device called the ram air turbine, a small propeller that drops from the fuselage and generates power using nothing but the wind rushing past the airplane. The philosophy is simple but profound. No single failure should ever bring an aircraft down, but some planes take this philosophy further than others, and those are the ones mechanics talk about with genuine reverence. Let us start with the Boeing 777, an aircraft that has earned almost mythical status among maintenance crews around the world. The 777 features 3 completely independent hydraulic systems, each with its own pumps, reservoirs, and actuators. The rudder alone receives input from all 3 systems through separate actuators, meaning 2 entire hydraulic networks could fail, and the pilot would still have full directional control. The flight computers operate on a triple redundancy architecture, where each of the 3 primary flight computers contains 3 independent processing channels built with different microprocessors and software from different manufacturers. Even if a software bug affects one channel, the others, running entirely different code, would catch the error and override it. By early 2025, over 2,300 Boeing 777s had been ordered worldwide, and the aircraft had accumulated one of the most impressive safety records in commercial aviation history. Would you feel safer knowing the plane you are boarding was designed so that its own systems argue with each other to keep you alive? Then there is the Airbus A350, a next-generation wide-body that represents a completely different approach to surviving catastrophic failures. The A350 introduced the automated emergency descent system, which automatically lowers the aircraft to a safe, breathable altitude if the cabin loses pressurization, even if every crew member on board is incapacitated. Think about that for a moment. The airplane can literally save itself and everyone on it without a single human touching the controls. The A350 also uses flight envelope protection, a sophisticated system that prevents the aircraft from ever exceeding its structural or aerodynamic limits, regardless of what the pilot inputs. Its backup flight controls are electrically powered, remaining fully operational even during a total hydraulic failure. Mechanics who work on the A350 often point to its composite carbon fiber fuselage as another layer of survivability, since it resists corrosion and fatigue, cracking far better than traditional aluminum airframes, maintaining structural integrity under stresses that would compromise older designs. The Airbus A380, the largest commercial aircraft ever built, also deserves a place in this conversation. Despite its enormous size, the A380 was designed with only 2 engine-driven hydraulic systems instead of the traditional 3. That might sound like a step backward until you understand the reason. Airbus replaced the 3rd system with electro-hydrostatic actuators and electrical backup actuators, creating a hybrid architecture that eliminates the vulnerability of having all hydraulic lines running through the same physical spaces. The lesson learned from disasters like United Airlines Flight 232 in 1989, where shrapnel from an exploding engine severed all 3 hydraulic lines on a DC-10, was permanently embedded into modern design philosophy. Engineers realized that routing multiple systems through the same area created a single point of catastrophic failure, no matter how many redundancies existed on paper. Now here is a name that might surprise you. The Embraer E-Jet family, particularly the ERJ 130, 140 and 145 series, holds a record that no other large production aircraft can match. With over 1,200 units built, these Brazilian-made jets have never been involved in a single fatal accident caused by aircraft failure. Not one. There have been minor incidents, like a jet sliding off a runway during a snowstorm at Chicago O'Hare, but never a single fatal victim from a mechanical or systems failure. Mechanics who service these regional jets often describe them as bulletproof, not because they are glamorous, but because their systems are elegant in their simplicity and incredibly reliable. The smaller Embraer jets use straightforward engineering that leaves fewer opportunities for complex system interactions to create unexpected failures. Sometimes the safest machine is not the one with the most technology, but the one where every piece of technology has been chosen with disciplined restraint. What do you think matters more in aviation, adding more systems or perfecting fewer ones? The Boeing 787 Dreamliner represents yet another evolutionary leap. This aircraft replaced traditional pneumatic systems with an all-electric architecture, fundamentally changing how backup power works. Instead of relying on engine bleed air for pressurization and de-icing, the 787 uses electrically driven compressors and heating elements, each with their own redundant power sources. The result is an aircraft where the loss of one system has far less cascading effect on others. The 787 also features electrically powered backup flight controls that remain operational during a complete loss of hydraulic power, a capability it shares with the A350, and one that mechanics consider a quantum leap in survivability design. The Bombardier CRJ series, the 700, 900 and 1000 models, also deserves recognition. These regional workhorses have compiled an extraordinary track record with no major in-flight structural or system failures on record. Airlines trust them for short-haul routes precisely because their maintenance requirements are predictable and their systems behave consistently flight after flight, year after year. Mechanics appreciate aircraft that do not surprise them, and the CRJ series rarely does. What ties all of these aircraft together is not just engineering excellence, but a philosophy refined through decades of learning from tragedy. Every modern safety feature exists because somewhere in aviation history, something went wrong, and engineers vowed it would never happen again. The fly-by-wire systems that protect aircraft from exceeding their limits were born from accidents caused by pilot overreaction. The separated hydraulic routing was a direct response to catastrophic failures that should have been impossible according to the mathematics of redundancy. The automated descent systems were designed because there were emergencies, where crews became incapacitated before they could act. Aviation in 2026 is safer than it has ever been. Fatal accident rates have continued their long-term decline, with the industry recording fewer than 2 fatal events per 10 million flights in recent years. The aircraft flying today are engineering masterpieces that carry within them the hard-won wisdom of every incident that came before. The mechanics who maintain these machines see what passengers never do: the layers upon layers of backup systems, the obsessive attention to routing and separation, the brilliance of designs that anticipate failures most people cannot even imagine. When a mechanic tells you that a particular aircraft could survive almost anything, that is not marketing. That is a professional speaking from thousands of hours spent inside the bones of these incredible machines. So the next time you board an aircraft, remember that you are stepping into one of the most carefully engineered environments ever created by human beings. If this video opened your eyes to the invisible engineering that keeps you safe at 37,000 feet, hit that subscribe button so you do not miss our next deep dive. Leave a like if you learned something new today, and drop a comment telling us which aircraft on this list impressed you the most. Or if there is another plane you think deserves to be here. We read every single comment, and your suggestions shape the videos we make next.